All right, let's talk more about triangles and relationships within triangles. So, a median of a triangle is a segment from the vertex to the midpoint of the opposite side. And it's a triangle, so there are three medians, and they are concurrent. And the point of concurrency for medians is called the centroid. The centroid is inside the triangle. So we're starting at the vertex and we're going in. Vertex, in, vertex, in. So it has no choice but to be inside the triangle. So from the vertex, from the angle, to the midpoint of the opposite sides of median, three medians create the centroid. And the centroid of the triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. So we've got 2/3 on this side, and we've got 1/3 of this side. So if AE, BF, and CD are medians of triangle ABC, then AP equals 2/3 of AE, BP equals 2/3 of BF, and CP equals 2/3 of CD. So the 1/3, 2/3 will apply to each median. That's the superpower of the centroids. So let's apply this. So in this triangle RST, Q is the centroid. Q is the centroid's made up of medians, so we know SW, RV, and TU are all medians of triangle RST. We also know that UV and W are all midpoints of triangle RST. So let's find QW. And QW is right here. Well, SW is 8, which is on the 2/3 side, and QW is on the 1/3 side, and 1/3 is half of 2/3, so it's going to be 4. And then SW, which is the entire median, is going to be 3/3, or 8 plus 4, 12. Let's do another example. So RST, point Q is the centroid. VQ is 5. We're going to find RQ and RV. So RQ is a side by the vertex, so it's the 2/3 side. QV, which we know is 5, is 1/3. So RQ has to equal 10, and then RV is going to be RQ plus QV, or 3/3. So it's going to be 15. And then I want to ask, what do we know about RU? Well, TU is a median. A median goes from the vertex to the midpoint of the opposite side. So we know that RU is congruent to US. RU and US are going to be congruent segments. Because it's the midpoint, it's in the middle, it's got to be the same on both sides. So now let's do some more practical applications with our coordinate plane. So here we've got triangle RST, get those coordinates, and first thing we want to do is we want to graph triangle RST. So we're going to go to 1, there's our R, 5, 8 is up here somewhere, right there, and T is 8, 3. There's our T. Here's our triangle. So let's find our centroid. Well, we know that we go from our vertex to the midpoint of the opposite side. Well, let's see, 1, 2. So the midpoint of RS is going to be right in here somewhere. The midpoint of ST is going to be in here somewhere. But the midpoint of RT is going to be in here somewhere. So I'm going to look for ST because it may make my life pretty easy. So let's find the midpoint of ST. Or of RT, sorry. I'm going to find RT. So the midpoint of RT is 2 plus 8 over 2. We're going to use the midpoint formula. 1 plus 3 over 2. There's the midpoint. So 2 plus 8 is 10 divided by 2 is 5. 1 plus 3 is 4 divided by 2 is 2. So the midpoint is at 5, 2. Right there, right where we thought it would be. So we have a vertical line. So now we just need to find the centroid. Well, the centroid is 2/3 of the way down this guy. So it's going to be right about there. So I can find the length of ST, take 2/3 of that, and that's where my point has to be. Or I can find the midpoint of another side, draw a straight line between those 2 points, because any 2 points make a line, and where that hits will also have to be my centroid, because wherever 2 lines intersect, 3 lines have to intersect, since the 2 lines can only intersect in one place. Let's do it both ways, just for fun. So we're going to find ST, and the equation of this line is x equals 5. So we can use the shortcut method and just do 8 minus 2, absolute value of, so that's 6, and 2/3 of 6 equals 4. So if I start at S, I come down 2/3, I get 5, 8 minus 4, or 5, 4, and there's my centroid P, 5, 4, right about where we thought it would be. Well, let's double check. Let's find the midpoint of RS, because then I can match that up with my vertex T and see if it crosses in the same point, see if our thought process was good. So the midpoint of RS is 2 plus 5 over 2. We'll call that V. And then we get 1 plus 8 over 2. So 2 plus 5 is 7, divided by 2 is 3.5. 1 plus 8 is 9, divided by 2 is 4.5. So that's where my V is. So I get 3.5 and I get 4.5. I'm going to be right there. So let's match these guys up with a straight line. And look at that, right through where I thought the centroid was going to be. So if I have a vertical line, I can just move down from my vertex 2/3 of the way. Or if I have a horizontal line, I can move from my vertex 2/3 towards the line. And that's where my centroid has to be, as we just showed here in our example. Let's do one more because we've got time and it'll be fun. So we're going to graph triangle ABC because we have a coordinate plane, we have coordinate points, so let's use them. So 0, 4 is A, -4, -2 is my B, and 7, 1 is my C. Okay, so let's see. AC, midpoint's going to be about here. That's not real helpful. BC, that's going to make it right around here somewhere. And AB is going to be, looks like it's going to be right around here. So we're going to find, just like we find the midpoint of RT, we're going to find the midpoint of AB. And whether it's easy or not, we're going to go with it. Segment AB. All right, so we get midpoint M is 0 -4/2 and 4 minus a -2/2. So we get -4 divided by 2, which is -2. And we get 6 divided by 2. Sorry, we add that. We add these, -4. So plus -4 plus -2. There we go. We got our signs right. 4 plus a -2, which is 2, divided by 2 is 1. There's our M, -2, 1. Oh yeah, that is definitely what we were looking for. So horizontal line with the equation y equals 1. So now let's find the centroid. So we're going to do the distance of C to M. So we get this absolute value of 7 plus 7 minus 2 minus a -2 equals 9. 2/3 of 9 equals 6. So I got to go 6 to the left from C. So 7 minus 6, 1. That is, let's get rid of that. So my centroid, P, is going to be 1, 1, 1, 1, is right there. There is my centroid. Keep it simple and just keep going through your rules until you find what it is you're looking for. So let's work So we know the centroid is P, right here. Because we have a triangle, it matches up the midpoints. Each path connects the midpoint of one side to the opposite corner. It means it's the centroid. So everything is 2/3, 1/3 in the middle, and midpoints are on the outside. So PS right here. And then we want to find PC, which is right here. When SC equals 2100, so that's 1/3, 2/3. SP is the 1/3. PC is the 2/3. So PS is going to equal 1/3 of 2100, or 700. And PC is going to equal 2/3 of 2100, or 1400 feet. All right, so let's find TC and BC when BT equals 1,000 feet. So BT is right here. TC is right here. So T is a midpoint. So if BT is 1,000 feet, TC also has to be 1,000 feet. And BC is BT plus TC, or 2,000 feet. All right, so find PA and PT when PT is this guy here in gray, is 800 feet. That is the 1/3 side. PA is the 2/3 side, so it's going to be double PT, or 1,600 feet. And then TA is going to be 3/3, or 2,400, or 1,600 plus 800. Still 2,400 feet. We will stop there and pick up altitudes in the next video.